Okay, all the operations in this video are going to involve something called the natural base e. E is a constant that's going to come up again and again in math. It's a lot like pi, which is a constant. So you know pi is equal to approximately 3.14159 ... right? And that number pi comes up a lot. Same with this number e. So e is approximately 2.718281, etc. And that number doesn't actually end there. It keeps going on. But we say that e is approximately 2.7. In the operations on this, we're going to treat e a lot like we do x. If you just see the letter e, you can treat it like a variable, unless it's asking you to actually evaluate it on a calculator. And then you can use the e button on your calculator. So for the first part of the worksheet, it asks you to do operations with e, like this. You're not actually going to use your calculator. You're just going to simplify it, get it as combined as possible. So in this first example, e to the second times e to the fifth, it's just like when we have x to the second times x to the fifth. We put our exponents together by adding them. This becomes e to the seventh. And I'm not asking you to use a calculator here, so you want to just leave your answer like that. That's as simplified as it's going to get. Letter B, you want to divide your coefficients that fall in the 3, just like normal, and subtract your exponents. So this will become 4 e to the 4 minus 3 power, right? We can top exponent minus bottom. Because 4 to the minus 3 is, 4 minus 3 is a positive exponent, this just becomes 4e to the 1. We leave it like that. That's as simple as it gets. Letter C, we want to bring that 2 in. That's outside. But you have to remember that the 5 is not attached to that e. The 5 has its own exponent. That's a 1. So when we bring the 2 inside, it's going to become 5 to the second power. And when you bring it in, multiply it by this exponent, it'll become e to the negative 6x, right? Negative 3x times 2 is just negative 6x. Then we have to simplify this final answer. 5 to the second is 25. And this, because it has a negative exponent, needs to move to the bottom. So it'll become 25 over e to the positive 6x. And that's as simple as that gets. Let's leave it like that. This is kind of a special case, so I put it on its own slide. If you try to simplify the coefficients here, well, we just have a 1 and a 5. So our final answer is still going to have a 1 over a 5 in it. The question is, what's going to happen to those e's? How are we going to combine those e's? Well, just like the example we did on the previous slide, you have to subtract your top exponent minus your bottom exponent. So e to the 4x minus, well, what is the exponent on that e? If it's not shown, it's a 1. We can't do 4x minus 1. It's not going to just become 3x, right? Because the 1 has no x attached to it. So in this case, that's actually as simple as this gets. The way you might see it written in a textbook, well, they wouldn't show that 1 on top. They might just show this. Okay? But you do want to show that exponent in parentheses, that 4x minus 1. It just looks neater to group that exponent together as a 4x minus 1. So it's e to the 4x minus 1 power over 5. Simplifying square roots or third roots, right? Any kind of root. We did a whole chapter on this previously. What we want to do first is jump inside and see if we can simplify what we have inside the square root first. Just reduce that fraction. We're leaving it all inside here for now. And then we'll worry about how we can get rid of the square root. So just inside, we have a 27 divided by a 3, which is going to be a 9. We have an e to the 11th on top and an e to the 3rd on bottom. And when we subtract that 11 minus 3, it's going to be positive 8. So the e to the 8th is going to come up on top and join up the 9. And then the x's, we want to take that x to the negative 4 and move it to the bottom where it's going to become positive. You'll notice that since we already have x squared on the bottom and it is staying on the bottom, that all together we actually have x to the 6th on the bottom of our fraction. So now that our fraction is fully simplified, we're going to deal with the square root sign. I always go to my denominator first and make sure that everything comes out of the radical. Can we do the square root of x to the 6th? We can, because we can pull out even groups of x. So we'll pull out x to the 3rd power, right? 3 groups of 2. And on the top, we're doing the square root of 9, which is 3. And e to the 8th, we're going to pull out even groups of 2. We'll be able to take out 4 of them. And this is the final simplified answer. And then finally, You should have a calculator out to do the bottom section because it's asking you to just evaluate it. And it says to round it to the nearest 0.01 or the nearest hundredths place when appropriate on my homework sheet. So when you type this into the calculator, you want to find the button that says this on your calculator. If you have a hard time finding it, bring me your calculator tomorrow and I'll show you where it is. And when you type that into the calculator, what's probably going to happen is it'll give you E, and it'll either put a caret in or just raise it up and ask you what you want to put as the exponent. So in that case, all you have to do is type in the exponent. Okay? So E to the 4th power, which when you do it on a calculator is going to come out to be a long decimal because E is a never-ending number. And you fill in 54.60 is what I got in this case. Okay? And in fact, I should not use that equal sign. I should use an approximately sign because it's not actually that number. We rounded it off. It's approximately that number. Again, for this one, you want to find the button that says e to the x power and get that on your calculator. It's going to give you this and let you fill in the exponent, which here is negative 0.09. So when we do e to the negative 0.09 power, it comes out to approximately 0.91. And that's it.